AI may feel weightless. A prompt appears on a screen. A response comes back in seconds. A company uses it to write, search, summarize, code, design, automate, or make decisions faster. But the AI boom is not only happening in software. It is happening in data centers, power lines, cooling systems, water networks, chip supply chains, and corporate balance sheets. Every AI answer begins somewhere physical. A server has to run. A building has to stay online. A cooling system has to keep working. A grid connection has to deliver electricity. And someone has to pay for it. That is the part of the AI economy most people rarely see. The public conversation usually focuses on what AI can do, the jobs it may change, the productivity it may create, the companies racing to build it. But behind the digital story is a much larger infrastructure story. And the costs are starting to come into view. According to the International Energy Agency, global data center electricity consumption is projected to more than double by 2030, reaching about 945 terawatt-hours, with AI as the most important driver. The IEA also says data center electricity use is projected to grow about 15% per year from 2024 to 2030, far faster than electricity demand from most other sectors. In the United States, that matters directly. The IEA says U.S. data centers are on course to account for nearly half of U.S. electricity demand growth through 2030. AI is not the only pressure on the energy system. Manufacturing, electrification, cooling demand, and broader economic growth all matter. But AI is adding a new layer of demand to systems that were already expensive, slow to expand, and essential to everyday life. That is the central contradiction. AI is sold as a digital revolution, but it depends on infrastructure that is physical, costly, local, and limited. The companies building that future already know this. Their spending shows it. Microsoft said it expected to invest about $80 billion in fiscal year 2025 to build AI-enabled data centers. In its 2025 annual report, Microsoft said it would continue investing capital expenditures to support cloud growth and AI infrastructure. Meta projected 2026 capital expenditures of $115 billion to $135 billion, driven by infrastructure investment for AI and its core business. Alphabet's 2025 annual report said the company expected to significantly increase 2026 investment in technical infrastructure, including servers, network equipment, and data centers. Reuters Breakingviews reported, based on Morgan Stanley estimates, that Amazon, Microsoft, Alphabet, and Meta were projected to spend about $630 billion on data centers and AI chips in 2026. That figure is an analyst projection, not a guarantee. But it shows the scale of the bet. Big tech is not just building software. It is building industrial infrastructure. For years, the technology industry used language that made computing sound clean and invisible. The cloud, the model, the platform, the assistant, the algorithm. But there is no cloud without buildings, no model without chips, no AI service without electricity, no 24-hour computing system without cooling, and no data center boom without a power grid that can support it. That is why AI has become an energy story. Reuters reported that U.S. data center power demand is expected by Wood Mackenzie to rise nearly 360% by 2030, reaching 110 gigawatts. That forecast may change, but it helps explain why utilities, developers, and energy companies are already reacting. Reuters also reported that data center power demand is pushing U.S. developers towards solar plus storage projects, while gas turbine waits average about 5 years. That detail matters because the issue is not only how much power America can produce someday. It is how fast new power can be built connected and delivered. Gas plants cannot appear instantly if turbines are delayed. Solar and batteries can help, but they still need land, equipment, financing, permits, and grid connections. Transmission lines and substations take time. A data center can be planned faster than much of the infrastructure needed to power it. This is where AI's cost starts to move beyond the technology companies. If new demand requires grid upgrades, the next question is who pays? Reuters reported in May 2026 that incentives for grid upgrades were being debated as data center demand raised concerns about power bills for households and businesses. That point has to be handled carefully. It does not mean AI is the main reason every electric bill is rising. It does not mean every household is subsidizing a data center. Utility rates depend on local rules, contracts, infrastructure, fuel costs, storms, regulation, and many other factors. But it does mean AI is becoming part of the cost allocation debate. If data centers require more electricity, more transmission, more substations, more backup capacity, or faster grid upgrades, that infrastructure has to be paid for. It may be paid by the data center operator. It may be paid by the utility. It may be paid by investors. It may be paid by ratepayers. Or it may be spread across several of them. That decision matters because electricity is not optional. It powers homes, restaurants, schools, hospitals, factories, offices, and small businesses. When grid costs rise, the pressure can eventually reach people far from the data centers themselves. For a middle-class family, that pressure may appear as another line in a monthly budget already strained by housing, insurance, groceries, and debt. For a retiree on fixed income, it may feel like one more essential expense moving faster than income. For a small business, higher power costs can affect margins, hiring, prices, and survival. For workers, the picture is mixed. AI infrastructure can create jobs in construction, utilities, engineering, energy storage, data centers, and chip supply chains. At the same time, AI automation may change labor demand in some parts of the economy. The boom creates opportunity. It also creates risk. Both are part of the story. The cost is not only electricity, it is also water. Data centers use water directly in some cooling systems and indirectly through the electricity they consume. Reuters reported that UN researchers expect data centers to consume twice as much power and water by 2030 because of AI-driven demand. Reuters also reported that North American data centers used nearly 1 trillion liters of water in 2025, citing Mordor Intelligence. Water use varies by facility and region. Not every data center uses the same cooling system. Not every community faces the same water stress. But the issue is serious enough that investors are asking for more information. Reuters reported in April 2026 that investors were pressing Amazon, Microsoft, and Google for more data on water and power use at U.S. data centers. That is an important signal. The cost of AI is not only being questioned by local communities or environmental groups. It is also being examined by investors trying to understand the long-term risks behind the infrastructure build-out. Power and water are not abstract inputs. They are local resources. A data center is built somewhere. It connects to a local grid. It may draw on local water systems. It may require land, roads, equipment, emergency backup, and public oversight. It may bring jobs and tax revenue. It may also create pressure on infrastructure that nearby households and businesses depend on. That is why AI's impact will not be evenly distributed. Some regions may benefit from investment and employment. Others may face grid constraints, water questions, or rate debates. Some utilities may be able to serve new loads without major strain. Others may need expensive upgrades. Some data center projects may come with dedicated power agreements. Others may become part of broader system costs. There is no single national answer. There are local trade-offs. That is one reason the AI boom is hard to evaluate. The benefits are often broad and future-oriented. Productivity, innovation, automation, faster services, new tools, and economic growth. The costs are more immediate and physical. Capital spending, electricity demand, water use, land chips, cooling, grid upgrades, and utility planning. The benefits may appear over years. The spending is happening now. That gap is visible in corporate budgets. When Microsoft, Meta, Alphabet, Amazon, and other firms spend tens or hundreds of billions on AI infrastructure, they are making a large bet. They are building capacity before the full payoff is proven. Investors may support that spending as long as they believe AI will produce future returns. But the scale of capital expenditure raises the stakes. If AI demand grows as expected, the infrastructure could become the backbone of the next digital economy. If growth is slower, if efficiency improves faster than expected, or if business adoption disappoints, some investments could look excessive. That uncertainty does not mean the boom is fake. It means the economics are still being tested. Forecasts are not facts. Energy demand projections can change. Some data center projects may be delayed or canceled. Companies may develop more efficient chips and models. Regulators may change rate structures. Utilities may require large customers to pay more directly for upgrades. Water rules may become stricter in some regions. Power contracts may shift more costs toward the companies creating the demand, but the direction already matters. AI is pushing more of the digital economy into the physical world. It is turning software growth into demand for electricity, cooling, infrastructure, land, and capital. And Americans should care even if they do not work in technology. The AI boom may influence where power plants are built, where transmission lines are needed, how utilities plan for demand, how investors value big tech, how local communities debate water use, and how much pressure lands on electricity customers. The wrong way to tell this story is to blame AI for everything. AI is not the only reason electric bills rise. AI is not destroying the grid. AI will not automatically cause blackouts, and not every data center harms the community around it. The more serious story is also more useful. AI is creating a new layer of demand on systems that were already under strain. It is asking the power grid to grow faster. It is asking water systems to support more cooling. It is asking investors to fund massive infrastructure before returns are fully clear. It is asking regulators to decide who pays when private technology growth requires public-facing infrastructure. That is the real cost conversation, not whether AI is good or bad, whether the economy is prepared for what AI physically requires. The next phase will not look the same everywhere. Some companies may build or contract for dedicated power. Some utilities may create special rates for large users. Some states may compete aggressively for data center investment. Others may become more cautious about water and grid impacts. Some developers may lean more heavily on solar plus storage because it can be deployed faster in certain cases. Some regions may push back if households and small businesses fear they are absorbing too much of the cost. None of those outcomes is guaranteed. But the questions are already here. Who gets the benefits? Who carries the costs? Who pays for the grid? Who protects local resources? And how much infrastructure should be built before the economic payoff is fully known? AI may change the way Americans work. search, shop, learn, and run businesses. But before it changes everything else, it has to be powered. That is the part hidden behind the screen. The server that runs, the cooling system that never stops, the water that may be used, the transmission line that has to be built, the substation that needs an upgrade, the investor capital that has to be committed, the utility bill that may eventually reflect a larger system under pressure. AI is booming, but the boom is not weightless. It has a footprint, it has infrastructure, it has trade-offs. And as the digital economy expands, its real costs are beginning to show up in the physical systems that keep modern life running.